Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Geometry class is where we are going to be writing proofs. There are many ways to format it, but the whole point of this is to understand how logical arguments work, whether you're going into computer programming, whether you're going to be a lawyer. Think about this. Let's say you're a lawyer and you're defending somebody on a murder trial. And you walk in there and you just say, he's innocent because I said so. They're probably not going to believe you. However, if you go in there and you say he's innocent, here is a picture with a timestamp of him being at a location 100 miles away from where the victim was, murdered in whichever aspect they were murdered in. Well, now you have given justification and reasoning or valid proof to why this person could not commit the crime. So our goal in math is to teach the thinking. And so we're just going to teach the thinking, and you're going to justify it with information about shapes. And therefore, you'll gain an understanding of how shapes work. And if you're going into construction or something like that, then it also gives you the benefit of understanding that. So there's a lot of little things going in on writing proofs, and you might be like, well, why? The entire point is just to get you to use logic and evidence to support your argument. Okay, and you have to have purposeful arguments. I don't know if you've ever been in a conversation with one where they talk about something and they jump to something else and they bring something else back and they assume you're going to connect all the dots and you can't follow their logic. So maybe they should have some practice in proofwriting, because maybe that would help what they're talking to you. So you can use some conjectures. So we've talked about things like a point. We can't really prove what a point is. We just kind of have to show it. So you can use postulates, but we don't use postulates in general. We try not to use them because they haven't been proven. We actually want to use theorems, okay? And a lot of times I will abbreviate theorems. So theorems are hypothesis or conjecture that someone has taken the time to prove. Okay, so let's just go over a couple theorems. Okay, the first theorem is vertical angle theorem. Okay, so the way theorems usually work is in a hypothesis and a conclusion. So if you're given this image, okay, now I'm just going to point out that 3 and 4 are vertical because, up and down. But if I rotate the image and I turn my paper, wouldn't 1 and 2 therefore be vertical? Absolutely. So this says if you're given this picture, then angle 1 is congruent or the same size as angle 2, and angle 3 is congruent or the same size as angle 4. Okay, why can they say that? Well, if we look at the reasoning becomes behind it, and I'll give a quick reasoning since we're looking at this image, is if we look at 1 and 4, okay, when we add those angles together by the angle addition postulate, they add up to a straight line. So 1 plus 4 makes a line. But doesn't 2 plus 4 also make a line? Okay, so if 1 and 4 make a line and 2 and 4 make a line, then because we're using angle 4 both times, wouldn't angle 1 and angle 2 have to be the same size? And the answer to that is yes. So that is an example of something that someone's taken the time to prove, and they've gone on to it and things like that. So vertical angles, again, the word vertical means they're, you know, in a vertical line, kind of like your vertical jump in basketball. So again, mathematicians not super awesome at naming things, but you need to know the words vertical angle theorem. And because they're vertical, they make the angles the same size, or congruent. Okay, complementary angles. Just so you know, complementary angles, this is a vocab word, are two angles such as a 30-degree angle and I'm not drawing these very well, and a 60-degree angle. If you notice, when we put those together, especially if you draw them well, you're going to get 90 degrees. So complementary angles are two angles whose sum is 90 degrees. Do they have to be touching? No, they don't. But when you add them together, they have to add up to 90. Supplementary angles are similar. They are two angles whose sum is 180. Now, you might be going, okay, but I might get complementary and supplementary mixed up. I completely agree. So many people do it. Do you agree that C comes before S in the alphabet? I do. I also agree that 90 comes before 180 on the number line. So these in the alphabet and the number line come before these in the alphabet and the number line. So if that helps you, C comes before S, 90 comes before 180. Okay, now we know complementary is 90 degrees, supplementary is 180. Okay, I can keep that. Okay. So here's another one. Okay. So here comes another theorem. The congruent supplement theorem. If measure of angle 1 plus the measure of angle 2 equals 180, and measure of angle 3 plus the measure of angle 2 equals 180, then the measure of angle 1 must equal the measure of angle 3, or angle 1 is congruent to angle 3, depending on which way you say it. So when I say the measure of, I'm saying the degree size. When I just write it as this way, I'm saying, hey, angle 1 is the same size as angle 3. So two ways to say the same thing. I don't care which way. So let's think about it. Let's give an example. Let's say angle 2 is 100 degrees. Well, what plus 100 is 180? That would be 80. Hey, angle 2 is 100 degrees. What plus 100 is 80. Did we find out that 3 was the same size as 1? Absolutely. Now, could we have done that with substitution and things like that? Isolate angle 2, isolate angle 3, do substitution and subtract? Absolutely. We could do algebra. We could say A plus B equals 180. C plus B equals 180. And we would find out that C equals B. Guess what? There's also a congruent complements theorem. Guess what the only difference is? Instead of 180, they use 90. If the measure of angle 1 plus the measure of angle 2 equals 90 degrees, and the measure of angle 3 plus the measure of angle 2 equals 90 degrees, then angle 1 is congruent to angle 3. Okay, and I actually kind of already mentioned this next one. Linear pairs theorem. Okay, I'm going to do this visually first. Here's a line, but I need a pair. So angle 1 and angle 2. So see how when I add the angles together, they make that line, hence the linear pair, because it's a pair of angles that are physically making a line when added together. So if you erased this, you would just have a line. That's what a linear pair is. So if the measure of angle 1, if angle 1 and angle 2 are a linear pair, then the measure of angle 1 plus the measure of angle 2 is 180. Now, are all supplementary angles, meaning do every one of them that add to 180 make a linear pair? No. A linear pair must share a side. Whereas a while ago I drew a supplementary angle, I could draw two angles here that are supplementary. I could draw a 90 degree here and a 90 degree here. Here they're only supplementary, not a linear pair. Here, now they are supplementary and a linear pair. So it depends on how they're drawn. They must share a side to be a linear pair. Do they have to share a side to be supplementary? No. Okay. So when you go to do your proofs, one, I've given you several things that we could use that most of it's pretty straightforward, you know. A linear pair, they're vertical from each other. Maybe complementary and supplementary were words you hadn't heard before, but we just gave vocab words to two things that had to 180 or 90. So when it comes to proofs, you have two types that we're going to focus on here. Okay? You can either do a 2-column. Okay? You'll give a statement with this and a reason. And this is basically your work and your why. For example, a 2-column proof, it would be like 3x plus 8 equals 20. Okay? So there's a statement. It was given. It was a problem. I gave it to you, right? So wouldn't we subtract 8 from both sides? So 3x equals 12 because we did the subtraction property. That's the official words, property of equality. Then we would divide both sides by 3. Why can we do that? That's the division property. So if you have an algebra problem, a 2-column proof is really easy to do because the first column is just your algebra work that you've been showing your teacher, and then the second column is the mathematical step you're doing. Like I could have really said, subtract 8 from both sides. Okay? And so 2-column proofs are extremely useful when it comes to algebraic. And I actually prefer them for geometric because it means I have to write less. However, there is another side that can come in handy, and that is a paragraph proof. Basically, it says the same things, but you're going to be using full sentences here. Okay, so the nice thing about a paragraph proof is if you forgot a vocab word, you can be like, well, because when two angles add up to 180 degrees, they make a straight line. Now, if I'm doing two column, I just say supplementary angles. But if you forgot those vocab words, then you can kind of really explain it in sentence form. So it depends on your problem and your skill, which is going to be easier for you. Again, I prefer the two column, but maybe you don't. So we're going to go ahead and we're going to go through a couple of the theorems, and we're going to see it as a proof. So the vertical angles theorem, okay? Vertical angles theorem. Do you remember which one that was? Okay, so that was, we were given, right? So 1, 2, 3, 4. Okay. So I'm going to say given, your given was you have vertical angles. And we're going to prove that the measure of angle 1 is congruent to the measure of angle 2. Okay? Okay, so here we go. Remember, we have to have our statement and our reason. 1, we usually like to bullet point these. Angle 1 and angle 2 are vertical angles. Why can I write that down? Well, because they told me. And instead of saying because they told me, we just write given. Okay. So 2. The measure of angle 1 plus the measure of angle 3 equals 180 degrees. Why can I say that? Well, I can say that because they are a linear pair. They're a pair of angles that make a line. I can also say the measure of angle 2 and the measure of angle 3 is 180. Why can I say that? The same thing. Okay. I can also say, and I'm going to put this in as, okay, I can say that the measure of angle 3 equals 180 minus the measure of angle 1. Or I could say the measure of angle 3 equals 180 minus the measure of angle 2. I just took statements 2 and statements 3 and I subtracted an angle to the other side, right? Using algebra. So usually when we do algebra, those are just things that I'm doing to keep it equal, and I subtracted to keep it equal. So subtraction the subtraction property of equality. And the same thing for line 5, right? Okay, so now algebra also allows us to substitute what the measure of angle 3 equals for the measure of angle 3. So by substitution, I'm going to say 180 degrees minus the measure of angle 1 equals 180 degrees minus the measure of angle 2. And that's by substitution. Then I can subtract 180 degrees from both sides. And I get negative measure of angle 1 equals negative measure of angle 2. So that again was that subtraction property of equality. And then finally, if I divide, I get the measure of angle 1 is equal to the measure of angle 2. And that would be by the division property of equality. and I probably should have written this without the m. Just angle 1 is congruent to angle 2. So 9, we now have angle 1 is congruent to angle 2, and that would just be definition. The vocab word is just a definition of congruent angles. And sometimes I don't feel like writing out the words, so I use symbols, right? So we were able to show with all the algebra. Could I have done this with different steps? Absolutely, I could have. But what I do notice is that we were able to get there. We used a little bit of geometry, a little bit of algebra. We kind of put it together. This is an example of a 2-column proof. So in the left, it was each part of my logic, and in the right, it was why I could do it. What rule allowed me to do it? Okay. So let's try another one. Given angle 1 and angle 2 are complementary. Angle 2 and angle 3 are complementary. Prove angle 1 is congruent to angle 3. Okay, this time instead of a 2-column proof, I could kind of give that as well. But we're just going to go ahead and go, hey, look. I was given that angle 1 and angle 2 are complementary. Which means they add to 90 degrees. I was also given that angle 2 and angle 3 are complementary. So they also add to 90 degrees because of the definition of complementary angles. This means that angle 1 plus angle 2 equals angle 2 plus angle 3 due to substitution So due to angle 2 being added to angle 1 and 3, angle 1 and angle 3 must be the same value for it to add to 90 degrees both times. Therefore, angle 1 is congruent to angle 3. Okay. We wrote sentences. The same thing. And just a quick note, here I could have substituted what 180 equaled, I could have actually put this in as substitution as well. That was another way we could do it. So there's always more than one way and more than one logical way we can get there. Sometimes you think a little different than the person next to you. That is okay. So 2-column, you just have 2 columns. One with the work, one with the reasoning. Here, it's just kind of all mixed together and you just kind of talk about it. Okay. Now, again, the proof idea, that part is just going, hey, why? The other thing your teacher might give you is just a picture. So it might just say solve for x. How can I solve for x? What can I do? Well, the first thing that we're going to do is we're going to say, how are these related? Well, they're related by vertical angles. And we just talked about vertical angles being congruent, which means they're the same size. So that means 6x minus 45 must be equal to 4x plus 5. And that was, I could write that because they're vertical angles. So see how as I teach you, I'm also reminding you of the 2-column proof? Why can we do that? Well, then what can I do? Well, I can subtract 4x from both sides, right? Subtraction, property of equality. Now you're probably past the point where you write that down every time, but when you do it, you get 2x minus 45 equals 5. And then you're going to do the addition property of equality, and you're going to get 2x equals 50. And the division property of equality, and you're going to get x equals 25. We have solved for x. Now there's not a degree sign on x because x wasn't part of the degree, but if you put it back in, you would find out that both angles were 105 degrees. Like 4 times 25 is 100 plus 5 is 105. So it depends on the question that they ask what your final answer is. This just said solve for x. They were vertical angles. I could set them equal to each other because vertical angles have the same side. Okay, so we're going to write one more proof and then we're going to call it good for this video. I'm going to give you an angle or an image and some information, and you are going to prove it. So I'm going to give you the problem and the answer. You're just going to justify the answer. Okay. So here's what you're going to be given. Okay, so we're given this information and we have to prove that. So I'm going to do this 2-column. And I number mine because that way if I use more than one line, and that was my given. Okay. So I find it extremely beneficial to go ahead and label my givens in the picture. So I'm going to put 35 degrees right here. I also know that angle 2 and angle 4 add up to angle 1. Okay, well that's kind of weird. Okay. So if I highlight these two lines, what do we notice it makes? If you notice that angle 2 and angle 4 were vertical angles, then that's an excellent eagle eye. Measure of angle 2 is equal to the measure of angle 4 because of vertical angles. Are there any other vertical angles? Absolutely, 1 and 3. So the measure of angle 1 is equal to the measure of angle 3. So that's why I left them all on 2, so I didn't have to write vertical angles twice. Okay, so if I can find the measure of angle 1, I can get the measure of angle 3. Okay? Well, in order to get the measure of angle 1, I have to add 2 and 4. So how big is angle? I know angle 4. I know angle 4. I need angle 2, but we just said they're the same, right? Okay, so line 3 would be that the measure of angle 2 equals 35 degrees by substitution. Or you could say again by vertical angles. Okay. So using substitution again, instead of changing out angle 4 to angle 2, let's go ahead and substitute in here. 4, the measure of angle 1 equals the measure of angle 2 plus the measure of angle 4, right? And again, that's by substitution. So if I simplify that, I find out the measure of angle 1 is 70 degrees. And that's because we added like terms, right? So up here we said the measure of angle 1 is the same as the measure of angle 3, so we're going to change the measure of angle 1 to the measure of angle 3. That's again substitution. And that's where I was supposed to end, so now I'm done. Okay, so again, that's an example of a 2-column proof. Could you have done that in a series of sentences? Absolutely. But all that was due to the fact that we were given certain information and we had a picture that showed us vertical angles.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.